Hey guys, in this video, we can discuss Leetcode 4252, two words within two edits of dictionary. So basically for this problem, we're gonna be given two string arrays, the queries and dictionary, and we wanna find all the words in the query, which is two edits away from any word in the dictionary. So let's take a look at example here. So we have four words in the query and three words in the dictionary. So for the first word, word, it's one edit away from this word would. So basically we just modify R into O so that they will be the same. So it's one edit away. That's why it's in the output. And for second word note, it's two edit away from joke. Basically we just need to modify N to J and the T to K to turn it into joke. So that's two edits away. That's why it's in the output as well. And for the third word ends, like we cannot modify any two characters to turn this word into any word here. That's why it's not in the output. And for the last word would, it's the same as this. So it's zero edits away from this word. So that's why it's in the output. So basically what we can do is like we can, for every word in the query, we compare to all the words in the dictionary. And if any of the word in the dictionary is two edits away, less than two edits away from this word, then we can have this word into the output. So in order to optimize, so the naive solution is just to compare every word into against any word, every word in the dictionary. So to optimize the solution, what we can do is like we can use a try. So basically we can build a try for all the words in the dictionary, and then we can compare every word in the query against the try. So if the word is two edits away from the try, then we can just have it in the output. So let's try to code it out. So firstly, we need a try. So the try can be a dictionary. And we need to build a try. So for every word, in dictionary, you can just add the word to try. Word to try. So just add the word to it. So we can define this function and we can implement that at a later time. So let me just define the function here. Add the word to the try. And now we implemented the try by adding the word to try, right? So now what we can do is like for every word in the query, for word in queries, we can just check the word in the query. And return the boolean. So if the word is in the try, then we can just append it into the output. Yeah. And we can define the function here and implement it at a later time. So we can, if the word is in the try, then we can append it into the output. We can return the output. So now we just need to implement the two functions, add a word to the try and then check the word in the try or not. So basically for adding the word into the try, we can just add every character in the word into the try. So for char in word, so if char not in try, we can just initialize that into an empty object. And then we can just recursively call this loop. So basically we can just point try to its child node. All right, so this will recursively adding all the characters in the word into try. Now we need to check the word in the try if it's like two edits away. So basically we can have to call the function to build a recursive function to do that. So basically we need a few more input parameters like the number of edits and the index. So initially the number of edits is like we can have two edits available. And then initially we start with index 0. So initially we have two edits available. So we need the exit conditions. So there will be a few exit, and the passing condition will be if idx is equal to the length of the word and the number of edits is larger than or equal to non-negative, then we return true. It's the exit condition for positive case. And if number of edits is less than 0, right? Otherwise, if we have less than 0 number of edits, then we just return false directly. All right. Now what we can do is like we need to compare the current character in the word against all the characters in the try to see if they are the same or not. If they are not the same, then we can minus the number of edits. So we can just use one of the edit and then recursively check if it works or not. So basically, we can just for every child, for every node, every character in the try compared with the current character in the word. So for char and the child try in try items. All right. So if char is different from the word index, different from the character, then okay, I need something called new edits equal to the number of edits. So the new edits would be so the number of edits we can have will decrement by 1. And if so, we can just call this recursively. So we can call it on the child try with the word, the new edits, and the next index. If it meets the condition, then we return true. And if we exhausted the loop and then still doesn't find a true case, then we just return false. All right, so this is I think this is all the code I need to write. Yeah, let's try to run and see. Yeah, looks good. Let's submit and see. Yeah, it works. So basically, this is the implementation of the solution. So basically, we can use a try so that we can optimize the solution so that we don't need to compare every word in the dictionary. All right, so this is the end of the video, and I'll see you guys in the next one.